The purpose of this project is to contemplate and execute SQL that derives tangible answers to questions pertaining to population in relation to WWDI database, exploring and analyzing the information to produce insights in report form. In this project, indicators are used to analyze a number of questions, whether mandatory or indicated as additional. The project database ERD helps visualize provided WWDI database table references and how others, such as World Bank indicators as well as additional analysis tables, are normalized to WWDI database. The mandatory end indicators used in population are population in largest city, population total, urban population growth, and net migration. Through the joining of the WWDI database and indicators, the execution of project questions helps to analyze the particularities of complex relations of tables, to analyze the questions given and to derive insights into World Bank population indicators in relation to WWDI database. A number of questions are asked and even created to perform this project. An executive summary, introduction, physical ERD, mandatory questions, additional questions, summary, and appendix are contained within this report respectively.
I use Dr. K WWDI database to perform the analysis, refine the population data we received from the professor, inserted the data into the database. Our research is based on 5 population indicators.
List countries which do not have any data for one or more of the 5 indicators from the topic your team selected. To answer this question, we use left joins and unions to query countries with missing data. The result is 60 countries. This is an essential preliminary analysis for further queries as it gives us an idea as to the variety of our data. We now know that there are many countries with missing population data. These are countries we should expect to be absent from future queries. Just from observing the table, it seems like many of the countries with missing data are those that are small in size. List countries for which data for all 5 indicators exist. To answer this question, we use left joins and intersects to query countries with filled data for all of our indicators. The result is 153 countries. Since all of the countries in this table have data for the 5 indicators, we should expect each of the 153 to appear in the future queries for population. Each of these countries have been keeping record of population data since the earliest date of our database up until the most recent. M3. List the indicators with the corresponding number of countries with data. Here we have a simple inner join query in descending order by country record count. There are 5 indicators in total. From this inner join query, we can see all of our indicators and the amount of countries that have data for each of our population indicators. This gives us a reference for future queries on our indicators. The output should have the same amount of rows as the country record counts for this question. As we can see, there are quite a few countries missing data for net migration and population in largest city. Show the top 10 countries in terms of most recent value for one of the indicators. Here we have another simple inner join query in descending order by date. This showcases the 10 most recent values for the population total indicator. It gives us an idea of how recent our data is for population total. If we choose to do a future query on population growth, we now know that 2018 is the latest date for our calculations. In addition, this table shows that countries with the most population are in Asia. China and India are the overwhelming top 2, with over 1 billion people each. List all continents with the corresponding most recent average value of one of the indicators. To answer this question, we use multiple inner joins to query data on population total. The result is 6 continents with data at the end of 2018. Note that Antarctica is not present, as it's missing data for this indicator. This table shows us the total average in descending order. Surprisingly, Africa is a leading nation even though Asia has the most countries in the top 10 in terms of population total. This tells us that Africa has numerous densely populated countries spread throughout the continent. Australia and Oceania has the least data as the average only calculates Australia and the surrounding island countries. Another surprise is that South America and not North America has the lowest average. This suggests that there are many countries that are not densely populated.
Question M6. Show all of your N indicators in a table of values for the US with indicator codes as columns, names, and dates in rows. Sort the dates in increasing order. Make sure to include the entire range of dates for your N indicators. Some cells will have null values. As can be seen in M6, every date in the sequence is shown in the table from 1950 all the way to 2018. Not all indicators have values within this time frame, and many contain nulls, such as in the last 3 columns. Indicators did not have dates for all the consecutive years. There were plenty of nulls contained within this table. All of the indicators were full joined in a sequence that allowed all of the indicators to have every indicator to have all of its values expressed within the table. First, the date was within the table, and then in sequence, every indicator had its values corresponding to that date.
Mandatory question number 7. Pick one of your indicators which is not gross percentage and calculate the average percentage of growth for each country for all years 2010 and later. Round the average percentage growth to 2 digits and order by the decreasing average percentage growth. To solve the question, I use the Urban total indicator to calculate the average percentage of growth for each country. The result is 211 countries, starting with Eritrea with a 9% average growth, followed by Oman with 7% average growth.
Use exists to find countries which have 2011 data for any of your 5 indicators. To answer this, we use a nested query with the exists function to find countries with 2011 data. The result is 213 countries in alphabetical order. This table is informative as it lets us know that in 2011, all of the countries in our database have population data for this year. Find countries which have 2011 data for all of our 5 indicators. Using an inner join, we answered this question. The result is 0 rows. Although all of our countries have population data in 2011, this table tells us that none of our countries had population data for all of our indicators. Each country had no values for one or more of the indicators in 2011.
Question A1. Show all of your N indicators in a table of values for Japan with indicator codes as column names and dates in rows. Sort the dates in the increasing order. Make sure to include the entire range of dates for your N indicators. All dates without null values in rows. Based on that question, there was only 12 rows that were present for Japan. that showed all values within all indicators. The table is ordered by date, and every date has a value because no nulls were allowed.
What is the relation between the inflation rate and the GDP per capita in the United States between 1960 and 2018? This diagram is created based on the table created from running SQL codes in the database. The data trends between 1960 and 2018 show a weak negative correlation between GDP per capita and the inflation rate. Other variables that are not available could cause the fluctuation of GDP per capita and the inflation rate. The model shows the total population by country and the top countries by population in 2018. China, India, and the United States have the maximum populations. An interactive map was created based on the model. Information regarding each country's name, location, and population count appears by hovering over the country location. Business entities can use the model to identify the area and the size of potential workforce worldwide. Governments and universities can use the map for census purposes.
In A4, what is the net migration of every country in the last 17 years for every country, with displaying the changes of every year? After executing the code, we have a table that includes column of names, largest migration by number, and the date of changes. We found out that in the last 17 years, Afghanistan took the lead for the highest number of losing population due to migration. On the other hand, the United States had the highest rate of accepting immigrants. Therefore, in this table, we can indicate what are the countries that sees migration out or in the last 17 years. These numbers helps to indicate which countries are losing population and which countries their population is increasing due to migration. In A5, what is the average population for all countries in Africa in period of 10 years between 1990 and 2000? In this table, we can find the population average over the period of 10 years. The average of population in Africa between 1990 and 2000 is near 49 million. This number can be used to determine the average population per country and the average GDP per capita of the African continent.
List country names which do not have any data for one or more of the N indicators, including all additional indicators. In the PDF report, but not the view, limit the results to at most 10 rows. There were 69 countries that did not have data on one or more of the indicators. Question A7. Find countries use names which have 2017 data for all of your N indicators, including additional indicators. In the PDF report, but not the view, limit the results to at most 10 rows. So there were no countries that had all indicators for 2017 as displayed in the table, which means that there was no country that had all indicators. So there were no countries that had all indicators, including the additional indicators, in 2017.
State the relation between the migration and GDP per capita. We create two views, one for the GDP per capita for each country in the year 2017, which is the latest available date, and another view for the migration for the same year. We then join the two views and order the rows by migration rate to view the relation between migration and GDP per capita. We notice that the countries with the highest migrant population are the ones with higher GDP, with some exceptions, of course.
Summary: the use of WWDI database in tandem with World Bank indicators pertaining to population brought new insights from disparate data sources through normalization. The tables that are created each question can be used for analysis and visualization, as well as the created tables can be used for future queries or within programming languages for data feature engineering. Some queries would have been difficult to answer if it were not for the use of syntax such as exist, union, intersect, view, etc., as well as the understanding of nested queries. Questions can be approached in unique ways, and optimization of queries should always be kept in mind on a big data scale.